little meddling. Alright, let's do some math. Log base 5 of x squared equals log base 5 of 2x plus 15. Now it seems like you know that if your logs are the same, the only thing that's different are what's inside the parentheses, and they have to be equal. So we're allowed to eliminate those to say x squared equals 2x plus 15. This looks like quadratic, so I guess I'm going to bring my 2x over and bring my 15 over. So it looks like we're going to factor this into a negative 5 and a positive 3. That adds to be negative 5 and multiplies to be negative 15. So my solution I got 5 and negative 3. If I put negative 3 into here and I square it, I get a real answer. That would be, what, 9? Negative 3 squared. You'd be squaring the negative 3. So yeah, that would be 9. And if I plug negative 3 into here, that would be 6. Negative 6 plus 15 is 9. 25, 10 and 15 is 25. So they check and they both work, and you don't get a negative value. You can't have a negative value that you're taking a logarithm of. Now you asked why it worked. That's a little bit more complicated. The reason the logs cross off, and I asked the whole math department this, the only thing we came up with was to switch this over to logarithmic form, which was 5 to the log base 5 of 2x plus 15 equals the exponent. And if these bases match, then you have 2x plus 15 equals x squared. That's where you would eliminate or drop the logarithm, because these bases are matching with your exponent. I don't love that explanation, but that's the best I came up with, showing mathematically why it works. Alright, and then the other one, this is the common log because there's no base written down there. Okay, I don't like this. Alright, 1 minus, you don't want a constant like that, so I'm going to add the log over here. So we're going to have log of x plus 9 plus log of x that equals 1. Now, because we're multiplying, or adding two logarithms with the same base, they're both 10, base of 10, common log, we're going to multiply x times x plus 9, which that would be x squared plus 9x. Now we would write this in exponential form, which is 10 to the first power equals x squared plus 9x, subtract our 10 across. So we get x squared plus 9x minus 10, and then we factor that. That looks like 10 and 1, positive 10, negative 1. So we get x equals negative 10 and x equals 1. If you plug negative 10 into the problem, you'd be doing a logarithm negative, and you can't do that. 10 to no power equals, or you can't be 10 to a power to be a negative number. So this is extraneous solution, and that's the only answer. I think we can demonstrate that on a graph, I think. Let's see if we can pull that off. So I've got the common log of x plus 9, and I have the log 1 minus common log of x. And if I graph those, I'm expecting them to only cross where x is 1. So we're going to look for that intersection. So if I do second calc, I can look for intersection. Is that my first curve? Yeah. Is that another curve, the graph that I'm looking for? Yeah. And its answer, let's see. Is exactly when x is 1. If you plugged 1 back in, you would get that to work out for a value of 1. But that's your answer. There is no answer of -10. Have fun.